For your information, this meeting is recorded and will be uploaded to public internet. So chances are whatever you say will remain for a very, very long time. So, all right, let's start. I have a couple of updates, but not that many for today. Then we can open up to question or comments that you guys may have. So one update is regarding gang scheduling. You know, this has been an effort that has been going on for a while. The most recent version of the gang scheduling proposal is close to final. There are like a couple of, more than a couple, but anyway, several minor comments on the design that I left yesterday, but otherwise the design is almost close to the final design for the alpha version of gang scheduling. If you're interested in the feature, please take a look. By the way, it's being called co-scheduling for, I don't know, some reasons that some people believe are valid reasons, particularly because of the connotation of gang with gangs. We decided to call it co-scheduling. So co-scheduling feature, which does not necessarily mean that all the pods are going to be scheduled on single node, but it just means that pods are scheduled together. This is a feature required for some of the HPC, high performance computing, as well as some machine learning workloads. Also, generally in batch processing, this is a feature that is sometimes needed. So anyway, if you are interested in the feature, please take a look at the proposal. The proposal is linked to our spreadsheet, and the spreadsheet is linked to our meeting proposal, meeting notes, which is in the calendar invite. That's one update. The second update is regarding the scheduling framework. So I have had the chance to start working on the framework, basically implementing some of the points. What we are going to do is to basically, in the very first version or very first PR of the scheduling framework, we are going to introduce the interfaces for a couple of extension points, particularly for pre-bind and reserve extension points. If you're familiar with the framework design proposal, these are two extension points used after a node is chosen, basically. And once we try to update the scheduler cache, as well as before binding a pod to a node, these two extensions are called. So we are, for the very first draft, we are going to introduce these extension points. Both of them are going to be alpha. So this is going to be a very first draft. Likely many things are going to be changed in the future, but I'm hoping that I can finish it in the next week or so, and I will send the PR soon. So with that, we are probably going to also start thinking about how to test this feature. So we need to introduce some testing infrastructure as well for the framework. If you have any questions so far, please ask as.
Yeah, one question. So the pre-bind and bind stage are more of a FYI thing to the extension points that this is the node being chosen. So any particular reason that we are starting with the first implementation is starting with these extension points, like in a sort of in a reverse chronological order?
So reserve is more like FYI. This is basically for mostly used for by the plugins that want to update some of, for example, a cache or a state that they're keeping. Prebind is an approval plugin, basically. So all the prebind plugins must return true for the pod be able to be bound to a node. If any of them return false, it's not going to be bound, and the pod is going to basically get rejected and go back to the scheduling queue for another attempt.
Which is similar to the current bind, right?
Yes, somewhat. Well, the bind today, we don't have any other checks basically today, right? So the scheduler today does not have any sort of checks after a node is chosen. It's just the bind at the API server that could possibly fail. This is more like another level of checks. And the reason that we chose these two particular plugin points to implement as the first ones is that there are a couple of features that would require these. One which is most important is dynamic volume binding. So dynamic volume binding is today implemented as as sort of like a hard-coded part of the scheduler. And in fact, it was one of the reasons that motivated us to think about a scheduling framework. We are not very happy with the fact that it's a lot of logic is integrated inside the scheduler core. So that's one of the reasons we would like to take it out. Gang scheduling is also going to benefit from a couple of these extension points, probably both reserve and prebind. It probably needs one more before we can actually implement gang scheduling using the current scheduler or scheduling framework. But anyway, these are also needed.
Yeah, thank you.
Sure.
Yeah, Bobby, one general question on
Yes.
the framework. So I think right now, the most recommended way for the user with minor efforts is to use the extender, right? To write some scheduler extender and implement their specific logic. So basically in the timelines perspective, so when do you think it's mature for user to use the framework as their most recommended way to customize the scheduler?
Yeah, sure. So of course, it all depends on what features of the framework needed, right? So probably, since we are implementing just the reserve and prebind as alpha features in the coming release, which is 1.13, we shouldn't be expecting users to have like a full-fledged framework in 1.14 or maybe not even 1.15. But in 1.14, we can possibly think about and maybe moving some of the extension points as beta. So 1.14 is probably going to be the earliest, but again, depends on the preferences of our users. Some of the companies that we work with, for example, never use any of the alpha or beta features. They want only GA features. So depending on your criteria and restrictions that you have, you may want to wait until it's GA, and that could possibly be, I don't know, a year from now.
Okay, got it.
Yeah.
Thank you.
Sure. So another update that I have is regarding our reviewers and approvers. So first of all, welcome Ray as our new reviewer to Gang Scheduling. To SIG Scheduling. I also removed several of the older reviewers who are not very active anymore. The reason that I did this is a lot of our PRs are assigned to these folks and need to be reassigned. And sometimes the authors of these PRs are not fully aware of the fact that some of these folks are not very active. And as a result, their PRs remain unattended. Basically, nobody looks at them. So we wanted to avoid this situation. So I actually sent a PR to change our reviewers, and I hope folks are okay with that. So I know that particularly I actually wanted to bring this to Avesh's attention. Rav is here. Avesh is not here, but Rav is, if you see Avesh, please tell him that I actually removed him from the reviewers list of SIG scheduling. If he thinks that he has the time to help us more with the reviews, I'll be happy to add him back.
Sure, I'll inform him.
Yeah, thanks. Okay, so there are also, there are also a number of PRs for the phase 1 of the scheduler refactoring. A lot of them are already merged or are almost ready to be merged. Jonathan is preparing the second phase. The second phase could be a little bit more intrusive, maybe a little bit change of some of the interfaces here and there, particularly around the priority and predicate functions of the scheduler. So I am hoping that Jonathan will have the time to start working on those and send those issues out soon. These are the updates that I have. Other folks, the owners of some of the features that we are working on, like pod limit priority function. Ravi, you're working on that. Do you have any updates on that? If you have, please share it.
So actually, I did not get time to work on that. And there is one more feature that Way and I have started on, taint-based evictions. I have increased the coverage locally. I did not create a PR for that. When I was testing it locally, the other thing that I've noticed is it's not as fast as normal evictions are, meaning the way we are calling the deletion from the node controller code. We were previously directly making calls to delete API for the pod on the node. It's not as fast as that. So I'm trying to create a benchmark, especially to see what is the impact of taint-based evictions. Hopefully I will have that up by tomorrow.
So do we use a different mechanism for taint-based eviction than deleting pods?
Yeah, so we are queuing all the nodes into another taint queue, and it depends on the number of workers in the taint queue, which are actually evicting the pods on the node.
I see. Okay.
So that's something that we need to look at. So I'm trying to create a benchmark for that. Even if it's at the unit test level, we should be good. But the only concern is if API server is on another host, it may be difficult, depending on the network bandwidth and the processing time on the node.
So, there are two approaches that I can think of. Of course, one is to have a controller that evicts all these pods from tainted nodes. The second approach is to let kubelet evict them, right? If the kubelet detects that a node that it's on is tainted, then it can start evicting pods.
So the taint manager is similar to a controller, and it has a queue from which it picks up the data. Picks up the pods that it needs to evict from.
Yeah.
But the number of threads that we are parallelly using to evict is the tunable parameter, is what I think at this point of time.
Okay. So I see.
Hey, Ravi.
Yeah.
I also have a question related to what Bobby just asked. Is why I was expecting like a race condition or like an issue with the taint-based controller with putting nodes on there and the kubelet with starting evictions, and the documentation says that there's a throttling implied here. So in order to avoid kind of a massive eviction of pods on a node, but I would also strive for the simpler solution with the kubelet, which seems to be a little bit more easier also from an operator perspective, configuring those things. So what is the kind of basically my question is, what is the added value instead of letting the kubelet handle this?
So kubelet is, as far as I understood, kubelet is the agent which is supposed to evict pods based on certain conditions. At this point of time, tainting or having unschedulable field is not a triggering point based on which kubelet evicts the pods. It is.
Sure, but the question is, of course, we know that the feature doesn't exist in kubelet today, but my question is that why can't we implement it in kubelet? I mean, the kubelet has the benefit that it's a lot more parallel as well, right? So if, for example, in a cluster, you suddenly decide to take down a whole zone with, 1,000 nodes, then you will have like 1,000 kubelets on 1,000 different machines that can work in parallel to evict all the pods, as opposed to like a single controller and a master node that has to take down, tens of thousands of pods.
I thought that's the job of node controller to tell. I mean, the eviction could happen from the kubelet side, but the node controller is the one that is responsible for telling, okay, I'm going to apply a taint or I'm going to set the unschedulable field. But I'm not 100% sure if kubelet is going to do the evictions based on the conditions that are set by external component. So if kubelet sets those fields, based on that, if kubelet is evicting, I think that's the way it is currently designed.
So are you saying that the kubelet does not monitor these things?
That's right. So like kubelet reacts to the main job of kubelet is to identify the problems on the node, and based on that it is going to take an action. It's not that the external influencer or the triggering point should be from an external entity. Rather, kubelet itself should do it, is what I think.
Okay. Yeah, I cannot really say this with confidence, so I don't know if that's really the case or not, but it's worth investigating, so, or at least taking a look to see if that would be an option. If it is, then it could be an alternative implementation that is more parallel.
Sure, yeah.
Yeah, Ravi, take a look at the PR that Klaus raised in 1.12 in the last minute of the 1.12, which is fixed performance of 10 node condition. So in the beginning, Klaus introduced a solution based on the old code of Tent Manager, I guess, which was used as a slice of channel. That is kind of doesn't perform well. So finally, he changed rate limited queue. That seems to work good. So if you want, I can point you out that PR.
Yeah, that will be great. I remember that PR. I think it was there was a scalability issue which Vortex has created for at the 5,000 nodes level, and Klaus has created that PR to solve that problem. But I am not sure the scalability test, or if it has started working fine because of the change. Because after the change has gone in, there were like a couple of times where the test was failing, and then after some time the test has started passing. So I do not know if the change that Klaus has introduced has solved the problem, but that's a good starting point. I can actually look into it.
Okay.
Yeah, thanks.
One more thing is kind of related, but not quite, is that, well, it's actually not related to the eviction, but there was this issue with 112 that if a cluster runs 110 or older pods, 110 is actually supported. We support kubelets, which are 2 versions behind the control plane. So if you run a cluster 112, you can run 110 kubelets. There was an issue with those. Klaus has sent a PR. It's not merged as far as I can tell yet. At least it was not merged until last night. So the issue was that 110 didn't, 110 kubelet didn't have the capacity or ability to check node affinity. So this was conflicting with the new daemons scheduling by the default scheduler. And as a result, some of these daemons scheduled by the default scheduler were getting rejected by those older kubelets in the cluster. Klaus has a PR out that is going to fix this for 112. Newer versions of the kubelet, like 111 and on, will have that change. I mean, the new changes. So those are fine. But if someone runs those older kubelets, they should be a little bit careful and ensure that this new PR that is being merged is included in the version that you're running.
Yeah, so I initially looked at the issue. I had a discussion with the person who has filed that issue. I was initially thinking that we could backport the change that Klaus has made for 1.11, I believe, or 1.12. We could backport it to 1.10, but Jordan, he told that we will not backport the API changes to 110.
Okay. Yeah, I guess we don't need to really, I don't know, we don't really need to carry all these changes forward because 110 is the last version basically that is supported with 112. And from the next release, 113, we are not going to support kubelets older than 111. 111 will be fine. So it makes sense to just add this change to 110 kubelets for now, I guess, for 112 release.
Yeah, and the other thing is we need to update the release blocks. That was the other thing that the issue filer was asking for.
Yeah, true. Okay, so Ravi, you have one more item on your plate, which is deprecate critical pod annotation. I don't know if you were going to have time for doing this, but given the number of contributors that we have and a lot of people who are asking for more work, if you don't have the time, please feel free to tell me so that we can reassign to someone else.
Yeah, sure. I think at this point of time, I'm kind of overwhelmed because of the OpenShift releases that are happening.
Okay.
So yes, I'd be more than happy to create an issue, and then if someone is interested, I'd work with him or her in the community.
Sure, yeah. If anyone present today in the meeting is interested, they can take the issue. Okay, I see. If not, we can actually create a help wanted issue on GitHub so that people can take it. Okay, that's pretty much all. We have 6 more minutes. If anyone else has any questions or comments or updates, please share.
I have one question related to Waze PR for pod affinity. I think there is an incubator project called Bootcube that Red Hat has started using extensively, and we found a bug in the latest version once that got merged. So I'll point it to way like offline, but I'm like curious if that is the thing that we are interested in carrying going forward. The patch that Way has.
Okay. So are we talking about like multiple pod satisfying affinity?
Right. That is the one.
Okay. Okay. Yeah. Sounds good. All right. Any other questions or comments?
I had one sort of a little naive question, so please feel free to ask me to look at any doc. I just had this question from the new scheduling framework. So to quote from there, we mentioned that that keeping scheduler V1 backward compatibility is a non-goal, specifically with the V1 extenders won't work in the new framework. So with this statement, did we mean that but the new framework also says that it will still have the out-of-process plugins supported. So does that mean the out-of-process plugins that will be supported in the new framework will just have new interfaces and the old interfaces will be not supported? Is that what it meant? Or
so that was our initial plan. Actually, later on, I don't know if I've updated. I actually later on tried to update. Maybe this is not updated correctly.
Yeah.
But, that was our initial plan. Basically, our initial plan was to build a framework from scratch, sort of. Mm-hmm. That got changed later on. We felt like it would be too much to build as well as to roll out, and particularly rolling out a new scheduler, which was not backward compatible, would take almost infinite amounts of time in clusters that run production workloads. So we decided to change that approach and go with building the scheduling framework features our Cantu scheduler. As a result, this new scheduling framework will remain backward compatible, and those extenders are going to be supported. We are probably going to introduce some new extenders, but for now, at least, we are going to support those existing extenders.
Okay. Thanks. And just one more thing related to it, that I mean, the in-process will definitely be the most driving forces, like I guess performance to prevent the marshalling and unmarshalling. But other than that, so in-process would definitely mean that we would need to recompile, or like from the document, it did not seem like one statement, I can't seem to locate exactly where, but one statement referred to that we might not need to recompile. I was kind of confused that how would we have in-process plugins which would not recompilation?
No, actually, given that we don't have a clean concept similar to like DLLs in Go.
Yeah.
Recompilation is going to be needed. Actually,
Yeah, right.
you may need to copy files into our current scheduler and maybe just register your plugin in our registration process.
Makes sense.
But otherwise, other than this and the fact that you need to recompile, hopefully you don't need to make any other changes, or you don't need to do any complicated merges of the code with the current scheduler.
Yeah,
but
sense.
Yes, recompilation is needed, and that's a bummer, but we cannot do much about it.
But we get the performance, so.
Yeah, exactly.
Yeah. Thanks. Thank you.
Sure. Any other question, comments?
About the tent-based eviction, so one update is that I have some conversation with Ravi and Klaus. So Ravi and I are working on that. So right now, Ravi are most focused on the increase the test coverage for unit test. I'm working on the E2E test. So once we are done, we can both working on improve the coverage on integration test maybe. So. And another thing is actually it's about me. So actually I didn't understand the tent-based eviction correctly. So my understanding was that the feature controls that if there is a no execute tent and it will evict the pod, right? But its behavior is not controlled by tent-based eviction. It's just controlled by internal no execute tent manager, no matter tent-based eviction is enabled or not. So what exactly tent-based eviction controls is actually if there is some not ready or unreachable condition comes out and this feature is enabled. It will.
Okay.
Sorry.
No, go ahead.
It will. Give the no execute 10 to the node. That's it. And based on that, it's not that it handles the eviction or not. It's not that case.
That's not exactly what Ravi said, though, right? So Ravi was saying that. So you're saying that taint-based eviction is just gonna detect the problems and taint the nodes. It's not gonna be actually responsible for evicting pods.
So by evicting, the behavior is controlled by a fundamental internal component, no execute tent manager. Yeah.
I see. So you're saying that already exists.
Yeah, already exists. And when I checked the E2E test, I found one funny thing is that the test was named by a postfix underscore test.go. So it's not enabled by default in E2E because it's treated kind of like a unit test. So I raised the PR to kind of also both rename it and also increase some coverage to test it on multiple pods and also to test on multiple toleration, which has different toleration sequence. Yes. But that is not exactly related to tent-based eviction, as I mentioned. Yeah. But that is kind of fundamental part to handle eviction generally.
Yeah. I see. Yeah, thank you. I need to actually educate myself a little bit on this. Looks like
I'm sorry, I lost the part where there was some confusion.
Ravi, we can talk this offline. I just understand it yesterday. So yeah, there is some misunderstanding on which part of the tent-based eviction controls. So
yeah,
we should understand it basically so that we can make good tests.
Sure. Yeah. We can discuss this offline. Like at a high level, we will just apply the taints, and there is a taint manager which actually evicts those.
I see. So the taint manager exists, and we don't need to make any changes there. That's, I guess, what I got.
That's right. Like at this point of time, we do not have to write code for the feature as such.
I see. Okay.
That's what I understood, at least looking at the latest code and testing that out.
Sounds good. Yeah. So now I understand a little better why you're saying that kubelet is not controlling that. Basically, it's not a part of this feature that kubelet does the eviction or someone else does the eviction. That part already exists, and it's not the responsibility of kubelet, it's the responsibility of the taint controller.
Yeah, in the node controller, we would, it runs like an external thing. Like we would we'll start the process which actually runs the taint manager. It has a separate queue and then it starts evicting. That's how it works.
Yeah. Okay. Sounds good. All right. Thank you very much.
And one last thing
Yeah.
for me is that the interpart affinity, which we are going to support, it match in multiple parts. So about that features, we need to kind of redesign, right? So I have worked out a draft version, but haven't checked in yet. So I'm gonna create some benchmark tests. I have some conversation with Harry, and I will create some benchmark tests and verify that it works well.
Okay.
So I hope I can check in before Jonathan's phase 2 refactoring. I don't want to, because phase 2 is kind of working on predicates priority, so you will have a lot of conflicts with the code I will.
Yeah, I know. Yeah, exactly.
Yeah, I hope to finish that before phase 2.
Okay.
Yeah.
Brace yourselves, phase 2 is coming. So,
Yeah.
All right. Okay, thanks everyone. So let's finish this meeting today. I hope to see some of you folks next week. See you.
Thank you. Bye-bye.
Thank you all. Bye-bye.